We have the most capable AI models in human history. Yet when most companies try to actually plug them in, the entire system goes dark. A recent study out of MIT looked at 300 real-world enterprise AI projects. They found that 95% of them produced almost zero measurable impact on the bottom line. The models themselves work exactly as advertised. The breakdown happens when organizations try to take those pristine, off-the-shelf models and deploy them into their own messy environments. This is known as the last-mile problem. It's the immense friction of taking a clean piece of software and forcing it to communicate with decades-old, fragile internal systems. Integration means navigating strict security compliance, red tape, and legacy offline servers. Most companies try to solve this by hiring outside consultants who hand over a slide deck of recommendations, or solutions architects who build offline proof-of-concept demos using fake data. But a slide deck doesn't write production code. To actually make AI work inside a real company, you need engineers who sit directly on the factory floor and build the plumbing themselves. The major AI labs are realizing this, and they are adopting a very specific playbook invented by Palantir over a decade ago. Palantir discovered early on that their advanced analytics software would only survive inside rigid government agencies if their own engineers flew out, sat down with the client, and wrote the custom integration code right there on site. They called this role the forward deployed engineer. Unlike an advisor, an FDE writes real production-level code directly onto a customer's live infrastructure. It reverses the normal logic of software development. A traditional software engineer builds one core capability and distributes it to millions of users. An FDE takes dozens of different capabilities and custom builds them for one single customer. By embedding directly with the client, the tech vendor takes total ownership of the final product. If the AI doesn't work in the client's environment, it's the vendor's problem to fix. This embedded approach relies on a strict four-step loop. First is the scope phase. Next comes the build phase. Then they hit the crucial deploy phase. This chart shows the final step, the prove phase. When a client asks for something vague like "put AI in our factory," the FDE digs into their operations to isolate one single solvable bottleneck. Here, the FDE writes the actual logic that connects an AI agent to the company's internal tools, usually working in standard languages like Python or TypeScript. They push this newly written code straight into the live enterprise cloud, dealing with strict security permissions and legacy databases. Before walking away, the FDE runs strict quantitative evaluations, measuring the AI's performance against a baseline. They stay until that stable graph translates into tangible business outcomes, like revenue lift or hours saved. Running through this exact loop is how you take a theoretical AI capability and force it to deliver a concrete financial return. Because this playbook actually works, we are seeing a massive hiring surge for FDEs across both the frontier AI labs and the major enterprise data platforms. The market demand is high enough that compensation for these roles routinely starts in the hundreds of thousands for mid-level positions and climbs well past $1 million for principal engineers. They command that premium because the job requires a rare T-shaped skill set. You need the deep technical expertise of a traditional engineer, including fluency in Kubernetes, cloud architecture, and modern AI agent frameworks. But you also have to stretch across the top, possessing the interpersonal skills to sit in a room full of confused executives, practice radical customer empathy, and thrive in total ambiguity. Finding someone who can write flawless deployment code on an airplane and then calmly translate that logic to a non-technical factory manager the next morning is incredibly difficult. As AI models become increasingly commoditized, the companies that win won't necessarily be the ones with the smartest algorithms. They will be the ones willing to do the grueling, chaotic work of actually building the bridge to the customer.